Hello, welcome to the first episode in a brand new series of Naked Neuroscience, the podcast exploring the workings of the brain and the nervous system in our bodies and beyond. I'm Katie Haler from the Naked Scientist team. And this month...
My parents live in an old Victorian house, and one day the door slammed out of nowhere, no windows open, nothing. And from that moment on, you know when you see a shadow in the corner of your eye?
I was up late and I was being creeped out by all these noises in the night, the things that go bump, and I just remember suddenly feeling a touch on my shoulder.
To mark Halloween, the spookiest night of the year, I'll be peeking out from behind the sofa at the science of fear, asking why some of us are so scared of seemingly harmless things, what's actually going on in the brain when we're frightened, and does cheese really give you nightmares? Plus, I'll be delving into neuroscience research hot off the press with the help of some local experts. So let's jump straight into some naked neuroscience news. Joining me this month to cast their eyes over the latest neuroscience papers were cognitive neuroscientist Duncan Assel from Cambridge University and perceptual psychologist Helen Keyes from Anglia Ruskin University. First up, I asked Helen what being a psychologist was all about.
Well, for me, I'm a perceptual psychologist, so I look at the way the brain perceives and interprets visual and auditory information. So for me, it involves a lot of experiments, a lot of computer experiments and driving simulators and things like that.
Now, as a humble radio producer who is going to take her third driving test in a couple of weeks, do you have any advice to help me actually pass?
Well, very embarrassingly, I only passed my driving test last year and I'm a professional driving researcher. So I think I almost failed the driving test, but I was telling my driving person that I was a driving researcher and he was so impressed that he was like, well, she must know what she's doing. So I passed. Oh. So I have no advice, but you could lie and say that you're a driving researcher.
Okay, thanks very much. I'll take that on board. Now, in a moment, you're going to tell us about what's caught your eye neuroscience-wise this month. What are you going to talk about?
How cognitive distraction can affect your eye movements and driving behaviour.
Very relevant to everyone, including me. So great, we'll come back to that. Thank you very much. Duncan Assel is a cognitive neuroscientist from Cambridge University. What do cognitive neuroscientists get up to?
Ooh, all sorts of things. In my case, we study cognitive processes like attention and memory, and we study them in children in our lab. And we're interested in why they vary so markedly across different kids and how do underlying brain mechanisms and brain physiology give rise to those differences.
And what paper are you going to be talking about? Is it learning related?
It is a little bit true to form. I've chosen a paper that's looking at the development of the hippocampus in childhood and what might influence it.
The hippocampus being a part of the brain?
Yes.
Okay, so let's start off back at Helen. Helen, can you give us a brief rundown of your paper, what the team was setting out to do, what they did, what they found, and why it's important?
It's all about when you see a visual sign, for example, a visual road sign, you actually say the words. So if you see a picture of a person with a shovel, you say roadworks, you say it internally, you articulate it. And that articulatory rehearsal is quite important for remembering and storing that information temporarily. So you see a visual sign, you need to rehearse it using an articulatory mechanism in order to keep processing it. So this paper was looking at people driving on a track and whether if they interfered, if they suppressed your ability to rehearse something, your articulatory rehearsal mechanism, if they suppressed that by getting you to count from 1 to 30, or even more complexly to count down from 50 down to 1, if they suppressed your ability to see a road sign and kind of rehearse it, would it affect your driving behaviour and would it affect your gaze? So they were eye tracking the participants while they were driving.
Okay, and did it?
It did. I'm not sure if the paper was quite successful. So the paper found that if you had a complex articulatory suppression, so if you had to count backwards from 50 when you were looking at a road sign, you had fewer gazes at the relevant visual information, you dwelled on things for less time, which says you were paying it less visual attention, and also you made more driver errors. So that's quite interesting, but it only happened for the complex suppression, so counting from 50 down to 1. It didn't happen for a simple suppression, counting 1 up to 30. which suggests to me that it's more of an attentional effect than just a suppressing your articulatory rehearsal. Because when you're counting 1 to 30, you're suppressing your ability to articulatorily rehearse something. So it should really have a similar effect if that was really what was driving this. But it looks like it's just a straightforward effect of if you're doing a complex cognitive task while driving, you're gazing at things in a less relevant way and your driver behaviour suffers.
So I'm guessing we knew this sort of thing before, right? Similar to not being on your mobile phone because that's cognitively distracting, maybe even talking to other people or shouting to your kids in the back of the car, that sort of thing.
Absolutely. And we know a few things about distraction. So we know usually that visual things distract you more on a visual task like driving. So the worst type of radio you could listen to would be listening to a football match being played. When you're using your visual imagination, it really takes your visual attention away from the road. But this is kind of suggesting that, yes, when you're distracted by hearing things, it's also going to affect your driving performance. We know that when you're talking on the phone, what's really distracting is the attentional capacity that's used. So if you're addressing a question or if you're really engaged, rather than sitting beside a passenger and talking at a more relaxed rate, that's not such a big issue. So mobile phone use is a problem. So it's not adding a massive amount of new things, but it is quite interesting just showing us directly that if you have an auditory cognitive task when you're articulating something in your head, even just thinking, that it's going to take from your visual attention. So thinking about cognitive tasks when driving, complex cognitive tasks, is going to be have a pretty big effect on your driving.
So don't try and do complicated maths problems whilst you're trying to drive up a motorway.
Well, how else would you get your kicks out alive?
Any questions, Duncan?
So if people's subvocal rehearsal mechanisms are important for how they process and maintain street sign information, we know there's a large degree of variability in how good people are at that. Does that mean that there's lots of variability in how good people are at taking on board and remembering road signs?
I'm really glad you asked that, because there's some really neat studies showing that a person's working memory capacity is directly related to the amount of driving errors they make. So that's exactly right. It just seems like your working memory capacity, if it's quite small, it's going to get used up quite quickly and you're not going to be able to process those signs or respond appropriately to your road environment. Yeah.
Okay, thank you ever so much. So, Duncan, we're on learning and memory now. So can you just remind us what your paper is about?
So my paper is about the development of a particular brain structure called the hippocampus in children aged 4 to 7. So we've known for some time that a child's early environment can shape all sorts of aspects of their development and can lay the foundations for lots of really important things, for instance, long-term mental health and all those kinds of things. So people have been really interested in what the mechanisms might be, but it's really hard to study it because, of course, it takes a long time for people to develop. And so as a scientist, it's really hard to study because you have to wait an awful long time to get your data. So one thing people have done is use different kind of models, like they've studied them in mice and rats and that kind of thing, who grow up a lot more quickly. So we know something about the mechanisms that might be important for how an early environment can shape things like memory over time. But what this group did, which was really, really nice, is that they collected fMRI data and structural MRI, so magnetic resonance imaging data of the brain, when children were 4 years old. They also collected lots of other things, sort of questionnaires about home life and about their parents and their parenting style. And they then saw everybody again 3 years later. And then one additional test that they did was a stress reactivity test. So they gave the children these very demanding tasks, and they actually adjusted the amount of time the kids had to perform them to the point that it became impossible. And that becomes quite stressful. And there's a hormone produced that you can measure in saliva called cortisol, which gives you a measure of how responsive people are to stress. So they have this really nice data set where over time they can explore how things like parenting change, how things like the hippocampus change, which we know is really important in memory, and how things like stress reactivity change. And what they demonstrated really nicely was that early environmental influences, in particular early parental behaviors, had a really strong impact on the growth of the hippocampus, and that it's much more reduced if parents have a very negative parenting style, and that the children are much more reactive to stress and stressful situations who have grown up in those environments. And that's a really hard study to run and a really valuable data set to collect. And it's really nice because it actually ties back to lots of the other biological work that was done in things like rats and mice, but it's one of the very first neat demonstrations of it in human children.
Okay, so what can parents take away from this study?
So what are known as harsh parenting styles, so a particular approach to discipline, for example, and rules. If it's extremely harsh, then that can actually have a negative impact on child development.
How harsh? Are we talking about telling people off, or are we talking about being aggressive?
Usually aggressive. So by and large, boundaries and so on, it's been shown to be a very good parenting strategy, especially in combination with a kind of warm and loving approach. But if parents show signs of aggression and are able to control their own tempers, then that can be seen as a harsh parenting style, and that can be shown to have a negative impact on kind of long-term health and brain development.
Okay, questions or comments? Helen?
How can we tell the direction of the effect? So if you have a child with difficult behaviour, maybe due to a small hippocampus, perhaps they, induce more aggressive behaviours in their parents.
Absolutely right. So it's very hard to disentangle these things. You can have a go at seeing what came first. And in their data, that the sample size isn't massive, it suggests that it's the parenting styles that come first. But your question kind of alludes to a wider debate about kind of chicken and egg, and these are kind of dynamic situations. And it's very hard to disentangle them. So even though in their data it looks cleaner, I suspect in the larger sample you would see that there are much more kind of subtle interactions between different factors.
That was Duncan Assel from Cambridge University ending that interview, and you also heard from Helen Keyes from Anglia Ruskin University. If you want to read up on those stories in more detail, you can find the links on the Naked Scientist website neuroscience page. That's nakedscientist.com/neuroscience. And if there's some neuroscience news that you want us to look at, or you've got a question that you'd like us to address, get in touch. You can email neuroscience@nakedscientist.com.
So what we were trying to do with this paper is to demonstrate the ability to type using brain signals, anywhere between approximately 4 and approximately 8 words per minute, a factor of between 2 and 4 faster than what's been demonstrated before.
Each month, the eLife podcast talks to some of the world's best scientists. Join me, Chris Smith, as I hear about breathtaking discoveries hot off the press. Find the eLife podcast on iTunes or listen and download for free from nakedscientist.com/eLife.
Imagine you're alone at home. You look out the window and realise it's dark. What was that? And that? Oh, it's only a door creaking open. It must have been the wind. Phew. Fear can get to us all in a variety of different ways, be it a haunted house, a tandem skydive, or even an intimidating social situation. So what can science tell us about this eerie emotion? And does fear really deserve its frightful reputation? Emma Cahill is a fear expert who lectures in neurophysiology at Cambridge University. So I spoke to her about the science of fear.
We've got so many words for being afraid, the heebie-jeebies and lots of different expressions. So it's not 100% clear in terms of language. But when you get into the lab, what we try to do is separate it out based on how obvious the threat is. So if something is uncertain and a bit ambiguous, it might lead to a state of anxiety, which is kind of long and chronic. If it's an obvious threat, that can have an acute response, which is fear. Fear is sort of two things at once. You have the bodily response to fear. You get the kind of heart racing, dizziness, maybe your muscles tense up, you can even feel a bit nauseous. And that's all down to what we call the autonomic nervous system. But you also have the thinking side of fear. These thoughts, they can be maybe a bit catastrophic or thinking of worst case scenarios, and that kicks off as well. And that's really what's controlled in the brain. Typically, when people are asked about what areas of the brain are used for fear, everyone jumps and says the amygdala, which is a small region shaped like an almond. But actually, there's a lot of different circuits involved. So you need your amygdala to basically learn about what things you should be afraid of. And it can also control that autonomic system from outputs it has down through your brainstem and out to the body. So it's a big, complicated mass of circuits. And there's no one region which is responsible for everything, but your amygdala clearly is a very important one.
Are we innately scared of things? Or do we have to learn to be scared of things?
A bit of both. You're more likely to be afraid of certain things, and that might be because we've been wired to be very easily programmed to be afraid, for example, of things like heights, which is a very common fear in humans, and that has a clear evolutionary advantage that you wouldn't go climbing up and falling off trees or anything.
So could you say the same thing about the dark, maybe? So don't leave your cave at night because you might get eaten.
Exactly, yeah. If you do have that sort of worry, you get sort of primed, so you're kind of on edge. And I think everyone has had this at home. If you've been watching a horror film, you switch it off, and then you hear something creak in the kitchen. You way overreact than you normally would if it was the middle of the day. And that's a type of learning as well. That's called priming. You're not aware of it necessarily happening, but it kicks in and it can make you form or even predict associations that aren't there. So it might just be that your cat has bumped into something in the kitchen and that's what the noise was. So you can definitely have learned fears as well. A lot of things that we try to study in the lab is that sort of artificial fear learning, where we try and couple a stimulus like a noise to something aversive. So it could be a loud bang or a puff of air. So that's associative learning, and that's a nice way to try and study how learned fear is acquired. Like most kind of emotional systems in the brain, fear is used to predict what's going to happen in your environment. And that's why I'm interested in it, because I'm interested in memory, and memory is just something used to predict things. So, like an everyday example would be, it's good to be afraid in Cambridge of leaving your bike unlocked, because if you weren't, you're probably going to lose it, and then you're going to have to walk around. If you were too afraid of ever losing your bike that you never use it and you leave it in a garage, so then there's no point in having it. So it's a balance. And I think that's an example of everyday situations. It's good to be a little bit fearful. I mean, who doesn't enjoy like a good, horror movie around Halloween as well? It can get your system going and that feeling alive. It's not just there to be a pest to us.
I'm a massive wuss, by the way. But when I watch horror movies or read scary stories and then go to bed, my imagination runs riot. Mm-hmm. Why do we just invent all of these ridiculous scenarios, which in the light of day seem ridiculous?
Well, my answer might be less neuroscience-y at this point, but I think some of the ideas about why we tell ourselves scary stories and make up these horrible situations is to sort of maybe prime ourselves and help us be used to something negative ever happening. One of the jobs of memory in general is to predict what's going to happen to you in the future, if you know what normally happens. So I think in horror movies, a lot of the time, it's a balance between something being, fantasy or sort of just slightly possible. So maybe it stretches what you think you should actually predict. And that uncomfortable kind of fancy word would be cognitive dissonance or something. So you kind of feel like, oh, do I really know what's going to happen? And I think it's that sort of unsettling that makes our minds race and try to make logical sense of what would actually happen. And, okay, that cortex kicks in and says, right, I'd be able to handle this because I would not run upstairs in the horror movie. I would go out the front door. You can get away from the cliches and plan your exit. So if ever anything did happen, you feel like you're prepared. I would guess that's part of what the brain is doing.
Don't go down into the creepy cellar and turn the light on.
Exactly.
Or maybe just don't go into the old, sinister-looking house in the first place. Emma Cahill there from Cambridge University. Now, fear, as Emma said, can be a very useful emotion, but cases of extreme fear can have a huge impact on your life. In the UK, phobias are the commonest of all anxiety disorders, which together affect over 3.5% of everyone on this planet. So why do some people get phobias in the first place? And what can be done to help them? Trainee medic Isabel Cochrane quizzed mental health researcher Olivia Reams from Cambridge University.
A phobia is this exaggerated fear response that you have when you are encountering a situation or an object or even an animal. It's basically a response to a situation which provokes a lot of fear, which is out of the ordinary. A lot of times you know that your response is exaggerated and irrational, but you can't control this fear. It is awful and you're consumed by anxiety and you're trying to do everything you can to get away from this object or this situation which is provoking this fear.
So someone with a spider phobia then, for example, what happens to them if they see a nice big fat hairy juicy spider sat around on their desk?
That is their worst nightmare. They will get a sudden spike of anxiety. They might feel dizzy, nauseous. They might start sweating if they have to endure that spider, if there's no way of getting out. And even just thinking of a spider or just looking at pictures of spiders, that can also induce anxiety in those people.
For someone who has such an intense reaction against a spider, is this necessarily because they've had a negative experience with a spider in the past?
There are many causes which could come into play, and research still hasn't unraveled all of the causes. They might have had a horrible experience with a spider or been involved in some kind of trauma in which spiders also played a role, and this manifested in arachnophobia, which is a fear of spiders later on. So this could very well be a factor. Or sometimes you develop a phobia because you see one of your parents having the same phobia, or because of your genes, you're more predisposed to have a little bit more anxiety than other people and to have this fear of objects or places. Also, a triggering event for one person might not necessarily be a triggering event for somebody else. And this is also where personality comes into play. So for example, there is a personality factor called neuroticism. You tend to be a little bit more anxious than other people. You are more likely to have low mood than others generally, and you are also more likely to develop phobias.
Where do we draw that line between a normal fear and a disorder, a phobia?
When the fear becomes abnormal and exaggerated, and when it becomes disorder, you start avoiding places because you don't want to encounter that situation or that object. If it impacts your day in such a serious and negative way, that's when normal becomes abnormal and it becomes a disorder.
For somebody whose fear is impacting their life in that very severe way, what kind of treatments are out there?
The treatments that are available include medication, but your doctor will be able to advise you on that and which medication is right for you if you do need it. Also, there is cognitive behavioral therapy or talk therapy. Essentially, you are seeing a counselor or a therapist, and they are trying to, in a way, replace the maladaptive thought patterns with ways of thinking that are more beneficial for you. So, for example, for people with social phobia, when you're afraid to talk to other people, to make contact with other people, often when they have conversations with others, afterwards they'll start ruminating about what they said. Did I say the right thing? Oh, I shouldn't have said that. And they beat themselves up over it. So one technique of cognitive behavioral therapy for these people is to wait to worry. Instead of worrying about how you performed at that social event then and there, you postpone it. And the reason that this is so effective is that our thoughts actually decay if we don't feed them with energy. So you might realize that when you come to your worry period, what you were initially so worried about isn't as bothersome anymore. Another very effective technique is facing your fears. You start small and then you build your way up. One example is if you have a fear of dogs. So your therapist might first get you to just think about dogs. The next thing that you might do is looking at pictures of a dog, because this gets your body slowly adapted to a dog again. And as you're trying to face your fear, you see and your brain senses that, yes, you are feeling anxious, but you can still cope with that. So your body is able to handle bigger challenges, like actually seeing a dog in real life. So that might be the next thing that you might do.
And for people who do seek treatment, do we have any idea how many of those people can expect to get better? And will they stay better?
It really depends on the person and how effective the treatment is for each individual. A lot of times, actually, people don't seek treatment, which is a problem. Sometimes people can get better and not have any more symptoms, but then the disorder can come back. Sometimes if you have an anxiety disorder, especially if it's starting when you're young, then that's when it tends to be more chronic. And if you have one disorder, then that can increase your risk for a second. What treatment helps you do is to just become a little bit more positive and to manage those things which are so distressing for you and to be able to lead a better life.
Well, you won't catch me cuddling any tarantulas anytime soon. That was Olivia Reams from Cambridge University, and she was speaking to Isabel Cochrane. And on the subject of phobias, fancy taking a guess at the terrifying objects behind these? Number 1, selenophobia. Number 2, ephebophobia. And number 3, gynophobia. Get your thinking caps on, you'll be finding out the answers later on. Now, whilst phobias might not necessarily be rational, at least you're awake when you're experiencing them. The dark, dreamy, nocturnal sphere can be very frightening, as anyone who's had a nightmare can tell you. But what can nightmares tell us about someone's mental health? To find out, I tracked down a nightmare expert.
My name is Katja Valli. I work at the University of Skövde in Sweden and the University of Turku in Finland. Nightmares are defined as emotionally negative, dysphoric dreams that lead to an awakening from sleep.
And what is actually going on in the brain when we have a nightmare?
Nightmares typically emerge from rapid eye movement sleep, which comprises about 20 to 25% of all sleep and is more prominent towards the morning hours. In rapid eye movement sleep, our brains are highly active, and especially the limbic areas, the emotional centers of the brain, the amygdala, even more active than during wakefulness. And these emotional centers of the brain, their activity during REM sleep could easily correlate with the emotional content of dreams and especially the negative content of nightmares. Another thing that happens during REM sleep is that the prefrontal areas of the brain, where we have our rational thinking and logical reasoning, but also emotion regulation, those areas are less active during rapid eye movement sleep than during wakefulness. So when the emotional centers are highly active, the centers that help us regulate our emotions, and especially our negative emotions, those centers are actually not active during REM sleep, suggesting that this is kind of like an emotion regulation problem in nightmares.
And do we know why we get nightmares in the first place? What's their cause?
Nightmares can be roughly divided into two different types. One is idiopathic. They occur without any triggering event, versus then post-traumatic nightmares that occur after a person has been exposed to a stressful, life-threatening event. But why nightmares overall occur, as well as why do we have dreams in the first place, is still a mystery to science.
So who is most likely to get nightmares?
About 3 to 5% of the population have nightmares more than once a week, and maybe about 30 to 40% have nightmares occasionally, once a month or so. And factors that can affect having nightmares might be, of course, traumatic experiences that result in post-traumatic nightmares, stressful life situations. We might have personality traits that make us prone to get nightmares, people who are kind of open-minded, trusting, vulnerable, might more easily get nightmares than people who have harder boundaries.
And do factors like age and gender make a difference?
Age and gender both seem to make a difference in a sense that women typically report more nightmares than men, especially in young adulthood. But in childhood, there really doesn't seem to be a sex difference between boys and girls. And by late adulthood, let's say by the age of 55 or 60, men have actually caught up with females on the frequency of nightmares. So especially young women report plenty of nightmares, while young men least nightmares.
So does that suggest that something's going on during puberty then, if there's no difference in childhood?
That is a very good question. In fact, in our group, we have hypothesized that sex hormones might have something to do with the frequency of nightmares. So that high levels of testosterone, which are typical for young men, might actually be protective of nightmares. And as the secretion of testosterone decreases with age in men, they actually start to get more nightmares. However, there are some studies that have not found this increase in nightmares with age. So we still have to be careful about saying that age affects the frequency of nightmares.
Can having nightmares tell us something about a person's mental state generally?
If I would take a single nightmare from a single individual, I wouldn't be able to say much about the person's mental or physical health. But if we look on the population level, people who report nightmares more often, they also have more often depressive symptoms or other mental health problems, such as anxiety disorders. Nightmares also correlate with psychotic disorders like schizophrenia. So on a population level, there is a correlation, but a single dream from a single individual really cannot be used to tell us anything about that particular individual's mental health.
And what treatments are on offer?
Both for post-traumatic and for idiopathic nightmares. There's a technique called imagery rehearsal therapy, which is relatively effective. The idea is to make a new version of the nightmare. So change the dream in any way the dreamer wants, write down the new version or tell the new version to a therapist, and then start practicing the new version in your imagination, especially before bedtime. And the idea here is that the nightmare has left a trace into our long-term memory banks, and we cannot erase that memory. But we can try to create a new competing memory that is more recent. And now when you fall asleep and the nightmare begins to evolve, what is activated from the memory banks is the new changed nightmare. There are also other treatments, such as trying to become lucid in the nightmare, which means that when you are having a dream, you become aware that this is nothing but a dream, that you are actually sleeping safely in your own bed. But achieving lucidity is not an easy task for many people. So that is why my first kind of treatment of choice recommendation would be to try imagery rehearsal therapy.
Katja Valley there. And I couldn't resist waving the old "does cheese give you nightmares" myth under Katja's scientific nose. But it turns out it might just stink. Apparently, a 2005 study done by the British Cheese Board found that their 200 volunteers didn't link cheese with nightmares. But, full disclosure, this wasn't published in a peer-reviewed scientific journal. It's not a very well-researched area, but Katja did mention one study in which some people linked particular food substances, including dairy products, to bad sleep or disturbing dreams. But perhaps, says Katja, it could be eating a heavy, fatty meal before bedtime and the metabolic strain that causes, which could be leading to poorer sleep and hence bad dreams for some. Now, remember those phobias I threw out for you earlier in the show? Well, let's see how you did against the Naked Scientist's office. First up, what is someone with selenophobia suffering from?
I have no idea. Are they afraid of silky skin?
Nope.
Fear of saltiness.
Not even close.
The moon.
Is the right answer. Secondly, what fear features in ephebiphobia?
People called Phoebe.
Nope.
Something to do with feet?
Youths.
Oh, well, that's just showing off. And lastly, what is genuphobia a fear of?
Really smart people.
People called Jen.
No.
Jeans? Like denim jeans?
What? Any other takers?
Genuphobia. Like genuflecting. Kneeling? Knees? Fear of knees?
Correct. We got there in the end. And very well done if you got 3 out of 3. And that's all we've got time for this month. Thank you to Emma Cahill, Olivia Reams and Katja Valley. as well as Helen Keyes and Duncan Assel. And thank you to you for journeying with me through the science of fear, phobia, and nightmare. Next month, we'll be traversing the science of memories, so do remember to join us then. In the meantime, you can get in touch via email. It's neuroscience@nakedscientists.com. And if there's a particular working of the mind that you'd like to hear about, let us know. I'm Katie Haler from the Naked Scientist team, and until next time, goodbye.